Previously we have seen the step-by-step process for merging the two sorted arrays such that the resulting array also will remain in the sorted fashion, right? Now let's just quickly write the pseudocode for the same functionality. So here basically we will write one function called merge two sorted arrays. Okay, anyway, as part of the problem statement itself, we will be given, if both the arrays are sorted in the ascending order or descending order. So I'm not putting the checks for validating to see if the arrays are really sorted or not, because I'm completely relying on the problem statement that the arrays will be sorted and given as an arguments for this function. So I'm not putting those checks in place, and the arrays are basically A, and let's just assume that B is the second array that we get. As part of the very first step, what I will do is I will read the lengths of these two arrays, which is nothing but, let's just say L1 is the length of array 1, and let's just assume L2 is the length of B. Now what we need to do is we are basically defining two helper variables, right? So that also I will initialize I and j, and I will declare both of them pointing to very first values in the array, that is nothing but the values at 0th index. One thing that you have to remember here is both I and j are pointing to the indexes in array 1 and array 2, which is nothing but I is pointing to the value in A array and j is pointing to the value in the B array. As part of the next step, what we will do is we will need to create the resulting array. In the resulting array, how many elements we will have? The number of elements in the resulting array will be equal to the sum of number of elements we have in A and B. As a result, we will basically create one resulting array. Okay, this is nothing but initialize, in which the length will be L1 plus L2. Okay, now we need one helper variable which will basically tell us what is the next index that needs to be filled in the resulting array, right? Let's just say that variable as current index, and in the beginning we need to start filling the values from 0th index, right? So I will initialize it with 0. Now after that, as long as we have values pending that needs to be compared from array A and B, we need to compare them and move it onto the resulting array. That's why what I will do is I will simply run a loop as long as the value of I is less than L1 and the value of j is less than L2. That basically means that we still have values that needs to be compared from array A and array B. In this loop, what we will do anyway, we will compare, right? So if at all the value that I have at array of ith index from array A, if it is less than or equal to the value at jth index, that means that array A has the smaller value. That means we need to use that smaller value to fill that appropriate position in the resulting array. To move the value from array A from ith index into resulting array, we need to fill the current index position in the resulting array. That's why result array of current index will be equal to array of I. Now we have used the ith value from array successfully, right? So we need to increment I by 1. So I is equal to I plus 1. Along with this, since we have filled the position 0 successfully, we need to fill the next position in the resulting array. That's why the current index also I will increment by 1. Okay, if this is not the case, that means that array B has the smaller value than array A. In that case, I need to use the value from Bth array to fill the current index in the resulting array. That's why if this is not the case, what I will do is I will take the value from array B. That means that the resulting array's current index should be filled with the value from jth index of the array B. Since we have used the value available at jth index of array B, we need to move on to the next element. That's why j will be incremented by 1 and current index also will be incremented by 1. Okay, so we are basically running this loop as long as we have valid values pending in array 1 and array 2 that needs to be compared, and based on their nature, we are moving them into the resulting array. That basically will not complete the logic, right? Because once we complete moving the values from either array 1 or array 2, there could be still some values that needs to be processed either on the array 1 or on the array 2. So we need to check if there are still any unprocessed values. If so, we need to move them into the resulting array. For that, what we will do is, let me just move this code to a bit side so that I can write the logic for that. After completing this logic, we certainly are not sure in which array we have the unprocessed values. They could be available in either array 1 or they could be available in array 2. So let me just write the logic for any of the values that are still not processed and moved on to the resulting array from array A, so that later on we can write the same logic for the array B as well. Let's assume that we have some more unprocessed values in the array A. In that case, whatever the value I we have, right, it will still be less than the length of the array only. That's why all the values from ith index till the very last value we have in the array A needs to be moved directly into the resulting array. That's why I will simply run a loop as long as the value of I is less than L1. In this case, resulting array's current index will be filled with the array A's ith index value. Okay, after moving the value of ith index, we need to increment it by 1 so that we will move on to copying the next value we have in the array A. And the next position that we need to fill will be current index plus 1. That's why I am incrementing it by 1. So as long as we have some unprocessed values, this loop will run and will directly copy all the values from array A2 into the resulting array. Why we ran this loop? In this logic, we basically assumed that all the values from the array 2, which is nothing but B, has been moved into the resulting array, and we still have some unprocessed values in the array A. Okay, but what if the values in the array A are completely moved into the resulting array, and there are still some unprocessed values in the second array, which is nothing but B? In that case, we need to run the similar logic for copying all the values from the array B into the resulting array. That's why we will run a loop while this J value is less than L2. In that case, 1 by 1 value from the array B needs to be moved into the appropriate indexes in the resulting array. That's why the resulting array's current index will be updated with the value at jth index of the B. Since we need to go to the next value, J will be incremented by 1, and the next position that we need to fill in the resulting array will be current index plus 1. That's why we are incrementing it by 1 as well. In the end, basically we have completed checks for moving the unprocessed values from array 1 into the resulting array, as well as array 2, which is nothing but B, also into the resulting array. So ultimately, after completing these two individual loops also, whatever the values we have in both array A and array B have been moved into the resulting array, such that the values arranged in the resulting array also remained in the ascending order. Okay, assume that here the pseudocode that I am writing is for the arrays in which the values have been given in the ascending order. If at all, if we get the arrays in which all the values are sorted in descending order, all the logic that you need to change is this comparison operation. So if you change that, you will basically have a algorithm for merging the two descending order sorted arrays, such that in the end the resulting array will contain all the values in the descending order as well. Okay, after completing these two individual loops, in the end we need to return the sorted merged array, which is nothing but R. Okay, so that is the effective way of merging of two sorted arrays, such that in the end the resulting array also will remain sorted. Now that we have understood the step-by-step process that is involved in the merge sorting algorithm, let's just try to analyze the time complexity and space complexity involved in this merging of two sorted arrays function. So here let's just try to analyze it in both best case as well as in the worst case scenario. Okay, When will the best case of merging of these two sorted arrays will occur? Whenever we have only one element in both array 1 and array 2. In that case, what we will do, whatever the while loop that we are running here, right, for comparing the two values and moving them onto the resulting array, this we will be running only once. And after that, based on whether we are moving the array 1's value or array's 2 value, one of these logics will be getting executed once. So obviously, if you see the implementation that we are doing, right, they are basically comparisons and moving the values into the resulting array. Obviously, since each and every loop is running only once and all of them are assignment and increment operations, so the best case time complexity will be order of 1. Okay. When will the worst case scenario of merging of two sorted arrays will occur? Let's just assume we have one array -1 0 3 4 and array 2 values we have are 10 20 30 40 50 60. Okay, in the array 1 we have 4 values, in the array 2 we basically have 6 values. If you dry run the logic that we have understood previously on these arrays, right, first basically we will move all these values into the resulting array. After that we will basically run this loop to move all the values from array 2 into the resulting array, because the smallest value in the array 2 is larger than the largest value we have in the array 1. So as part of whatever the while loop that we are running here, we basically move all the values from array 1 into the resulting array. So let's just assume the number of values we have in the array in such case are n, and let's just assume that the number of values we have in the second array are m. In this case, whatever the while loop that we are running for comparing the two array values from ith and jth index, this will be running n number of times. And after that, whatever the while loop that we are writing here will be running m number of times. As a result, the overall time complexity, what we can say is order of n plus m. Okay, so that is the time complexity of the merging of two sorted arrays. The other way is also possible. That means that all the values we have in the first array could be larger values. That means 10, 20, 30, 40, 50 are the values we have in the array 1, but the array 2 has values 1, 2, 3, 4. In this case also, we will basically move all the values from array 2 into the resulting array first, and after that we will be running this loop for whatever the n number of times that we have. As a result, still the outer loop will be running for m number of times here, and n will be the number of times that we are running this loop. As a result, still the time complexity will still remain order of n plus m only. Okay, now let's move on to the space complexity analysis. To analyze the space complexity, in the best case where we have only one value, right, obviously whatever the variables that we are creating for storing the lengths and storing the appropriate indexes that we are processing, they will anyway take the constant amount of memory only, and whatever the resulting array that we create will also have two values in it, because in the individual arrays we are getting one value, right? As a result, resulting array will also have only two values. In that case, obviously we know how much memory is being consumed by only two values. As a result, resulting array will also take only constant amount of memory. After that, anyway, whatever the while loops that we are writing are not taking any memory, because all of them are basically update statements in the previous values that we have created. As a result, in the best case, the overall space complexity will be order of 1. Okay, and in the worst case, basically the array 1 we are assuming having n number of values, and array 2 we are assuming that we are having m number of values. As a result, whatever the resulting array that we create, right, in this resulting array we will basically have n plus m number of values. As a result, the total amount of memory we consume for creating this resulting array and moving the values into that resulting array will be order of n plus m. Okay, so that is the space complexity in terms of merging the two sorted arrays such that the array will still remain sorted in the end. Okay, now that we know this merge two sorted arrays functionality implementation, let's just go ahead and let's just try to use this function in the implementation of merge sort algorithm.